Hello. Today we're going to learn about the Pythagorean theorem, and we're also going to be exploring some more properties of square roots or radicals. Before I get into the lesson today, I want to remind you that your notes, you should be taking notes after watching this video or during watching this video, and your notes need to go into your portfolio, and I will be checking your portfolio for these notes at some point. Go ahead and title your notes Pythagorean theorem. And the Pythagorean theorem is a really important concept to learn in geometry because it helps us figure out the length of sides of triangles. And also we're going to be using it later on, after Thanksgiving break, in determining the distance between 2 points on a line. Let's go ahead and write down the definition of what the Pythagorean theorem is. So what the Pythagorean theorem is, the purpose of it is to find the lengths of the sides of right triangles. So the Pythagorean theorem is used to find the lengths of the sides of right triangles. And the formula for the Pythagorean theorem, this should look familiar to you, is a squared plus b squared equals c squared. So a squared plus b squared equals c squared. And what a, b, and c mean are this. They're different parts of a right triangle. Okay, so say like we have our right triangle here. I'm going to go ahead and draw a right triangle. And this is not very straight, I apologize. And say like that's our right triangle right there, or a right angle, excuse me. We always make A and B the lengths of the sides, the base and the height of the triangle, and we always make C the hypotenuse. So here I want you to go ahead and make a note saying C is the hypotenuse, or the longest side of the triangle. Okay. We're going to do some examples together, and then I'm going to refer you to the pages in your packet so that you can practice this concept. Okay, so our first example is this. Say like you have a triangle. So let's see, example. Say like you have a right triangle. One of the sides of the triangle is equal to 9. The other one's equal to 12. And we don't know what the hypotenuse is. So it's C. We're going to write our formula a squared plus b squared equals c squared. And we're just going to make one of these sides right here a and one of the sides b. So we'll plug in 12 for a. So 12 squared plus 9 squared equals c squared. Okay, so 12 squared simplifies to 144 plus 81 equals c squared. We're going to add those two together. And when you add them together, you get, I'm going to bust out my graphing calculator here. 144 plus 81, 225. Equals c squared. And to go backwards, to get rid of this square, you do the opposite, which is take the square root. And so you have to take the square root of here, and c equals, and if you want to, you can use your calculator, so square root of 225 equals 15. So the length of the hypotenuse is 15, and that is your answer. Oops, sorry about that. Okay, let's do another example. Say like instead of trying to find the hypotenuse, you're trying to find the length of the side of a triangle. So example number 2. And hopefully your notes are a little neater than mine. So you have a right triangle. We don't know the length of this side, so let's call it B. We do know that this is 24 and that this is 25. Again, we're going to write our formula. A squared plus B squared equals C squared. We know A is 24, so we're going to do 24 squared. We don't know what B squared is, so we're just going to leave it as B squared. And we know that C is 25 squared. Okay, and now I'm going to go ahead and solve these square roots. If I were a good student, I would already know what 25 squared and 24 squared is, but I don't, so I'm going to do it on my calculator. So 25 times 25 is 625, and 24 times 24 is 576. Okay, so let's see here. This is 625 is equal to B squared plus, and let's see what it was again, 576. To get B squared by itself, to solve for it, you gotta subtract 576 minus 576. B squared is equal to, let's see here, 15. This becomes 12, 5, 9, and I didn't do this right, it's supposed to be 11, okay, so 49. Take the square root to get rid of the square right here, so then you get B equals 7, and that is our answer. Okay, so now that we've done two examples of using the Pythagorean theorem to find the lengths of the sides of right triangles, I want you to go to your packet and go to page 29, and I want you to try the problems on this page out. Okay? So go ahead and pause the video and you can do those problems and practice them. Okay, so the next skill that we're going to learn here is we're going to learn some more properties of radicals or square roots. So go ahead and title the next section of your notes, Properties of Radicals or Square Roots. And the first skill that we're going to learn today about radicals is how to square radicals and what that all means. So go ahead, you can make a section heading that says squaring radicals. Okay, so the best way to teach you how to do this is just to give you examples. Now I'm going to write a reminder here, just to remind ourselves that squaring is the opposite of taking the square root of something. Okay, so I'll do some examples. Okay, so say like you have the square root of 9, and we're told that we need to square it. Okay, what does this all mean? Let's go ahead and simplify what we have inside the parentheses here. And we know that the square root of 9 can be written as 3 times 3. and we're going to keep the parentheses and the square around it. Okay. Now we also, if you remember from the previous lecture, that if we see two numbers of the same kind, twins, we can take these numbers outside the house, which is what I'm about to do. So then we can write this radical looking like this, right? 3. And then we still have the parentheses in the square. And 3 squared is the same thing as saying 3 times 3, which is equal to 9. So essentially, we've just done the long way of proving that squaring something is the opposite of taking the square root. Okay? Because we ended up getting the same thing that we had under the radical. Alright, let's do another example. Square root of 25 squared is the same thing as saying square root of 5 times 5 squared. And since 5 and 5 are twins, you can take it outside the house, and we get 5 parentheses squared, which is the same thing as saying 5 times 5, which is equal to 25. So again, we got back what we started with under the radical. So the general formula for this is anytime you take the square of a square root, you always end up getting whatever number is under the radical. Okay. So now that we know how to do this, I want you to go ahead and in your packet, you're going to turn to page 23, and there's a section right here that says squaring radicals. Go ahead and try those examples.